Hello everyone, welcome back to LeetCode Daily Life, where I do the daily question, raw and uncuts. So we have a medium called minimum deletions to make string k special. So let's see what the question wants. So you're given a string word and an integer k. So the word is 100,000 long at most, and k is also 100,000 long at most. And the word only has lowercase English characters. So we consider a word to be k special if the frequency of word I minus frequency of word j is smaller or equal to k. Does that mean like the number of that character for all indices I and j in the string? The frequency of word I. Yeah, I think what it means is like if you have three a's and then you have like two b's here, then the difference would be like one here, right? I think. So, okay, it explains it here. So frequency x denotes the frequency of the character x in word, and y denotes the absolute value of y. Yeah, okay. So my hypothesis is correct before. Return the minimum number of characters you need to delete to make word k special. So let's look at example 1. We have this. So, right. So what does this do? So I think we can either make all of them length 1, right? So we can remove like 3 A's, 1 and 1 B, so that'll be 4, or we can remove C and remove 2 A's to make like 2 A's and 2 B's. So that's the best solution here. And then for word here, so for example 2, we have k is equal to 2 in this case. So it is saying that so therefore word becomes equal to this, where, well, if we make the frequency of b to be 2, we have to remove all the a's, and then like frequency of c to be 3, frequency of d to be 4, that'll work. So yeah, okay. Yeah, and then we have example 3 here. So on first glance, you might have to like remove the a's, but actually if you just remove the b, well, every character would just be a, so this thing would always be equal. Okay, that's kind of interesting. Well, so my first observation for this question is we obviously want a counter for these type of questions, right? Because we don't really care about the position. We care about the actual frequency of the 26 lowercase characters. So I guess we can look at example 1. So example 1, we will have 4 A's. We have 2 B's. Right? Yeah, we have 2 B's, and then we have 1 C. So if we want to make them okay, I think that now that I've written this out, I kind of have some idea. So we can always remove like one, like all of one character. Like we want to like test different minimums, right? So like for this case, well, we can make C the minimum, and we can we can remove like all the frequencies that are more than 1 until it matches like whatever k is. So if k is 2, like it'll have to be at most 3 here. So like we can test how many characters you have to remove for that case, and then we can like just get rid of C completely, or well, get rid of like all the characters that have a frequency of 1. So we like obviously we have to like calculate the number of operations for that as well. So if we remove all the C's, it will take like 1 remove, right? So in this case, our B would be the minimum, right? So we have to make sure the rest would have to be like at most 2. Well, in this case, well, it has to be exactly 2. I guess we can like also look at example 2, but Do you want to do that? I think I already know how to code it out. So yeah, let's just code this out. And the time complexity for this, like even though you have to like remove each of them, the time complexity is actually really really good because you only have 26 lowercase characters, so it'll basically be constant. You can say like 26 squared operations, kind of. So I guess you have the initial counter initialization, so it'll be on, but other than that, it's pretty cheap in terms of time complexity. So yeah, let's just code this out and see how we go. So first thing is we want to import counter, right? For our word, so like we can turn all of them into some some frequencies. And actually we don't even need to know like what character correspond with which frequency. We are really only interested in the frequency. So for values. Yeah, so we only care about the actual frequencies, right? Like if we go back to this, we didn't actually use the fact that C has a frequency of 1. We just care about the 1 there. So so I think we should have a best here. We'll set it as like we have to remove the whole string first. So we just do like length of word. Because that's like the worst case possible, right? If we want the running best here. I guess another thing we can do is we can just sort this and then reverse it. Reversed. I hope this is but then I have to like turn it into a list, I think. So sorted reversed list. I'll kind of tell you why I want to do this in very very short time. So yep, so what do we want to do? Do we maybe we can even like combine them together, maybe? Does that work? No, I think that's a bit of a stretch. So I'm thinking of like using a set to combine the equal frequencies together, but I don't think we have to do that. Wait, actually, maybe we don't have to do that. Like we can use an index thing instead. So while index is smaller than length of frequencies, so when we look at the first frequency, well, what do we want there? Well, first of all, we need to like set the operation. So so like let's look at this case, right? If you have like 1, 2, and 4, and when your index is like here, that means we want this to be the minimum, and then we want to make everything after it like match this minimum. But when we get to like here, because now this is the minimum, we have to get rid of like all the stuff before that, right? And if we have like 2 1s, well, it doesn't matter, right? Like if we get rid of like both of these 2 1s, or well, if you're like looking at this and you get rid of this one, well, because we have checked this already, and like the first one is definitely more optimal than like making the second one like the minimum. We can we can kind of just like do this case and like ignore it. Like it will never be better. So we can do for I in range all the way to index. Operations, we will add frequencies I in there. And now for I guess we need the current minimum as well. So that will be frequency of index. For I in range, index all the way to length of frequencies. index plus 1 because we don't actually need to deal with the current minimum. So we need to do. So how much do we have to add? Well, so I think it will be a max of 0 all the way to frequencies of I minus current min. So if you think about this, if our current min is 1, our frequency is 4, and our k is 2. Well, we have to move this down by 1, right? So actually, I think it should be something like this. That makes a bit more sense. Yeah. And we know that frequency is always bigger than current min, because the array is sorted. And the minus k here is like we only have to like make this difference like exactly k if it is like more than that, right? So that's the most optimal operations we have. And then after we do that, and we also don't want this to be negative because we can't like add more characters in, right? So we can just do best equals minimum of best and operations, and then at the end we can just return best. So I think that should work. I hope. Oh, what is that? I forgot to do this. Yeah, that's why it is timing out. And well, we have to kind of wait for it. Okay. Nice. I'm pretty sure I don't run into any edge cases for this. Yeah. Okay, cool. So I'll talk about how I thought about the solution. So I think like for this question, the most important observation that you have to make is that it doesn't really matter like what word I and word J is. Because like what does the frequency thing mean? It means like the number of time it occurs in the string, right? So if you have like a bunch of A's, so you have like a bunch of A's and like a bunch of B's, well, if your I is like this and your J is this, like it's only looking at the actual character, right? Like if your I is like now here, it'll still be the same result because like the character is the same. So once you notice that the position of the characters in the word does not actually make any difference. Well, if that's the case, how do we want to deal with the frequencies? Well, we can just combine them together, right? Like we can just use a counter. Like we only care about the actual amount of like frequency, and once we have a bunch of frequencies, I don't know, something like something like this, let's say. Well, how do we know all the possible like case special strings we can form? Well, we can't just like we can't just look at the minimum and say, oh, we can just make like all of them as small as possible, right? Because what if we have like 1, 10, 11 and k is 1? Well, if you just make this the smallest, and then we have to like make everything match the smallest, well, it would be a lot of operations, right? So what if we just get rid of that completely? Like now it actually just becomes a k special string right here, like if k is equal to 1. So I guess like after I noticed that, I can see that we can kind of like mix like exhaustion. So exhaustion means like checking every possible outcomes, and greedy to to like make sure we checked every single possibility. So if you make something a minimum, so if you make this a minimum, well, what is the best case for that? Well, the best case is if you just make each of them like just small enough so that it fits the like the k special string requirements, right? So like the frequency like minus the minimum has to be like equal smaller than k. So in this case, like you just make all of them 2, and I don't think like you can argue too much with that, like with that greedy approach. Um, but what if we just check every frequency as a possible um current minimum? So if we check 10 as well, well, how do we make 10 the minimum? Well, by getting rid of like all the frequencies before that, right? But if we get rid of that, we have to like add into our operations as well. So because like we are removing all the characters like before that, and then if we make this the minimum, well, again, we can like just do the greedy approach and like make each of the frequencies just small enough so that those frequencies are, well, like the difference of those frequencies are like smaller and equal smaller or equal to k. So yeah, that's kind of the intuition behind this question. But yeah, I don't think this question is too difficult. But if you have like if you want me to clarify anything, feel free to comment below. And yeah, if I help you out in this video in any way, please like the video and subscribe. I'm trying to reach 200 subscribers, and if you have any feedback as well, I'd love to hear from you guys. Like if you have any questions you want me to do, I'm just really busy right now, but I'll probably just like keep a list, and like eventually I'll do the questions that you guys want me to do. So yeah, thanks for watching, and I'll see you tomorrow. Bye.